Welcome you all to the course on Smart Grids Basics to Advanced Technologies. In comparison to the conventional power grid of last 20 years, have you ever wondered how smart our electrical network has become to meet the exponential growth of electricity demand every year? It has become smart by the incorporation of new sourcing of smart components and operational techniques. This includes wide area monitoring system, islanding detection techniques, phasor estimation, and digital relays for smart grid protection, along with modern demand response management and its analysis for smart grids, which has been covered briefly in our previous course titled Introduction to Smart Grid. The course Introduction to Smart Grid was popular, and I thank all of you who have taken the course and successfully completed the examination. I am confident that all of you must be using those concepts in your day-to-day applications, classes and labs. We felt that the course on Introduction to Smart Grid need additional laboratory exposure which can further help you to take the concept of smart grid to its next level. Hence, we designed a new course titled Smart Grid Basics to Advanced Technologies in such a manner that along with the basics of smart grid, an updated version including laboratory experimentations of necessary modules has been added. We have added 11 experiments such as solar and wind generations, PHIL experimentation for symmetric and asymmetric fault analysis of grid connected DFIG wind turbine, grid connected DC microgrid, parallel operation in AC microgrid, energy management in the microgrid, peak energy management using energy storage system, battery management system and EV charging and many more. We are very confident that this course is unique among the online teaching material available in NPTEL. We hope and wish that this course will necessarily help you to understand fundamentals along with helping in teaching, research and experimentation. So, now let us start with the lecture 1, Introduction to Smart Grid. First of all, let us understand what is the meaning of electrical energy grid. The moment we talk about electrical grid, it means electric grid is a network of synchronized power providers and consumers that are connected by transmission and distribution lines and operated by one or more control centers. Being said that, now you can see the view of energy grid or electrical grid. We do have generation stations, transmission lines, substation step down transformers and connected across different type of loads. The generating station which is ideally transfer its energy through either EHP AC lines or HPDC lines, and the voltage rating of those EHP AC lines are either of 800/765 kilovolts, 400 kilovolts, 220 kilovolts and 132 kV. Whereas, the commonly used HVDC lines are of 500 kilovolts. The customers, especially the sub-transmission customers, connected at 33 kV, primary customers at 11 kV and secondary customers, we residential, are at 400 volts. Now, the different components of electrical grid to me is generation first, which is either of thermal type, hydro type, nuclear type and very recently renewable energy sources. Now, the transmission, as being told recently, it is either of high voltage AC or high voltage DC. The distribution system, mostly it is AC type, but in the recent time people started talking about DC type too. The consumers, as we all know, they are industrial types, commercial types and residential or domestic type. The electrical energy grid structure historically vertical in nature, that is, the energy is being produced at generation point or generator stations, then being transmitted through transmission lines, distribution lines and reaches to the consumers. But with the new technology and the mega penetration of renewable energy at low voltage levels may allow the energy to flow not necessarily from top to bottom, but it could be from the bottom to top too. So, the vertical structure currently may have two different forms, that is energy flowing from generation to consumers and the energy may flow from consumers to generation stations too through transmission and distribution. The history of power grid is quite interesting. If you look back, Thomas Edison, considered to be the father of direct current distribution, who perhaps created DC technology, and then hence Nikola Tesla, again we treat him as a father of AC distribution system. Tesla invention for long distance AC distribution were commercialized in competition against Thomas Edison's short distance DC distribution system. And eventually AC systems or AC distribution won the day due to its lower cost and higher efficiency in distributing electricity over long distance. So, I wish to conclude at this stage that though DC distribution was equally popular, similar to AC distribution, but over a period of time it has been realized that AC distribution system is more economical compared to DC distribution, especially when you are transmitting through long distance. Further, to add, Sir Adam Beck, the father of Ontario's electrical power system, Beck believed in the principle that publicly owned power at cost to the people, and Beck built the power system with government debit, which was paid back in users fee over the lifetime of the assets. Now, that is how today we see the whole world is depending on AC system, which is reliable, robust, working well for long distance transmission. But in recent time there are two new things which are coming up. The first one is presence of renewable energy at all the voltage levels, and the DC technology cannot be discarded completely as it was before many decades. Now, looking at Indian national grid, a quick glance, in early 60s, grid management on regional basis started. State grids were interconnected to form regional grid. India was demarcated into 5 regions, namely northern, eastern, southern, western as well as northeastern regions. In October 1991, northeast and eastern grid were connected, and during March 2003, western region and eastern region as well as northeast region were interconnected. August 2006, north and east grids were interconnected, thereby 4 main regional grid, that is northern, eastern, western and northeastern grids are synchronously connected, forming central grid operating at one frequency, considered to be a great achievement during 2006. 31st December 2013, southern region was connected to central grid in synchronous mode with the commissioning of 765 kilovolt Raichur Solapur transmission line, thereby achieving one nation, one grid, one frequency. So, dear listeners, I wish to conclude that the energy grid of India achieved one frequency, one grid in the month of December year 2013. Now, look at the authorities of Indian energy sector. Ministry of Power, which is the major component, deals with planning, policy formulation, processing and implementation of projects, enactment of legislation in regards to power generation, transmission and distribution. Next important body, which is Power Grid Corporation of India Limited, responsible for national and regional power transmission planning. Then we move to Central Electricity Authority, advise on matters related to national electricity policy and formulation of short term and perspective plans for development of power systems. Then next, Central Electricity Regulatory Commission and State Electricity Regulatory Commissions regulates tariff, formulates policies regarding subsidies and promotion of efficient and environmental policies at central and state level respectively. Then we move to Central Transmission Utilities and State Transmission Utilities develop efficient, coordinated and economical system of interstate and intrastate transmission lines. Now, if you look at the impact of electrical grid in specific, global demand of energy is expected to climb about 25% by 2040. It is a great hike. The whole world is expected to increase their per capita energy consumption, and it is a great challenge in front of all of us how to achieve that 25% increase by 2040 in a green, clean manner. Above and all, India contributes about 45% of world energy demand growth in 2040. So, being said, the whole world is worried about creation of energy sources in a cleaner, a green manner, whereas the challenge on India would be far more, because out of those 25% increase by 2040, 45% increase is just by India. India and China show the largest increase, with each reaching more than 1 billion middle class citizens. India will grow strongly with its share of global GDP doubling. Now, if you look at the key figures of our country in 2016-17, the population is 1.32 billion, which is huge. The total area that we possess is close to 3.287 million kilometer square, and the energy mix, we do have energy from oil, coal, gas, nuclear, hydro and renewable. The electricity consumption, it is in terawatt hour, which is 1114, and whereas electricity generation capacity as on March 2017 was 326.8 gigawatt. The very challenging component is overall network losses. It is reasonably high, which is expected to be far lower than what is being mentioned. Currently, it is 22.7%, which is extremely at higher end. So, we need to try our level best to make sure the energy does not move a long distance and it is efficiently being utilized, so that the loss can be dropped down by few percentage in near future. And certainly, the smart grid we are going to talk in detail end of the lecture today will certainly help us expect it that the distribution losses will drop further. If you see the Indian power sector, the energy share, we do have the major share from coal, which is as high as 59%. Then we do have renewable, which had a wonderful stake of 17%, followed by hydro, which is 14%, and then we have
nuclear and diesel are of single digit and gas is of double digit percentage contribution respectively.
But I am very keen to mention something very specific here, that the renewable energy contribution in India is close to 57 gigawatt, and that is close to 17% of the total energy mix. And it is a good idea, and we will keep on increasing those renewable contribution in future to achieve the low carbon footprints in this country and contribute to the global challenge in achieving green energy in future. Now, if you look at the current status in this country, the installed capacity over last 10 years, you can see that the wind energy installation is keep on increasing, the PV is also keep on increasing, the biomass is also keep on increasing, and the hydro is keep on increasing. So, today we can easily see the hydro, which is very close to 40 gigawatt, and my wind, which is very close to 28 gigawatt, and my PV, which is very close to 8 gigawatt, and my biomass, which is close to 6 gigawatt. But one interesting scenario that we all can see here, when you come back to the year 2020, now we can see that the PV installation will go as close to 98 to 100 gigawatt, which is a great challenge, and followed by the wind, which is close to 60 gigawatt, and then the hydro may go up to 78 gigawatt, and then the biomass may be close to 10 gigawatt.
So, in 2022,
maybe another 4 to 5 years from now, we are going to add as high as 250 gigawatt of renewables in the system. So, we need smarter technology to accommodate those renewables for stable operation of the energy grid. Now, if you look at the energy mix, this is what the report says. I mean, in the October 2016, if you take the one of the data, in the first column we can see that the total mix, energy mix is 6,287 for the month of October itself, and it has combinations. So, the energy is coming from wind, solar, biomass, okay, and small hydro and others. So, this gives me an idea how the energy mix from especially renewable sources on a particular month. So, we can see the pattern in which how it has been generated. We can see for October 2015, and then this is completely April 2016 to October 2016, which is a 6-month period, and as well as for 2015. So, reasonably we are at good position with respect to renewable power generation and their mix as well as the energy production. Now, what are the major factors affecting the performance of the existing grid? Now, as we all seen that we are keep on putting generations over years, because the demand is keep on increasing, the expectations from the public is keep on increasing, the per capita energy consumption is keep on increasing, and hence the one of the major factor that puts us in risk today is huge increase in demand of electricity. Supply shortfall of electricity means there is a energy gap between what we produce and what we expected to deliver. So, they two do not match exactly, and perhaps the energy production is slightly less compared to the energy expected during peak hours. The need for reducing losses, one of the major factor, as you say, and we are at very close to 22% of distribution loss that need to be reduced. Peak demand management means today, especially during peak hours, we experience peak shortage of close to 4 to 5%, and that need to be reduced by putting maximum generations. And one thing I like to highlight here, when you like to reduce the peak energy gap by putting energy sources, it is very difficult to go for huge nuclear or hydro or thermal power plants that may take actually 6 to 10 years time from now. So, very quickly you cannot meet out your peak shortage. So, the only one way I could see at this point is that putting renewable energy sources as maximum as possible in our country that lead to achieve excess generation installed capacity and may reduce the gap between peak energy requirement and energy available at that time period. Now, integration of renewable energy generation system. So, as I mentioned, we have to go for renewable energy to meet the peak energies peak demand management, but to do that we need to have technology which can perhaps integrate safely and for reliable operation of those sources connected at different voltage level. So, integration of renewable energy generation system also do poses challenge. Now, solution to global warming, we all have to contribute. Effective use of electric vehicles, currently they are randomly being manufactured, and especially the electric vehicles in India, it is mostly electrical rickshaws, and the charging discharging pattern are never been technical, and they need to be organized so that the charging can be done during off peak period, and discharging is not possible, but at least the charging can be respected. But in next 5 years time from now, the electrical vehicles may contribute for discharging during peak hours. Now, better customer satisfaction, quality power or energy, overcoming difficulties in meter reading. So, currently we have all manual readings that can be made automated, and poor efficiency of conventional power generation systems. Most of the thermal power plants today are getting old, aged, and their efficiencies are coming down day by day. Potential of technological advancement and new business opportunities. Aging assets and lack of circuit capacity. Most of the assets in this country are 40 to 50 years old. They required quick replacements, and power network design life is need of replacement, which is the biggest challenge. The capital cost of like for like replacement will be very, very high. Security of supply, need reliable electricity supply as more and more critical loads are connected. Thermal constraint, transmission and distribution lines at its limit, Most of the lines are congested or overloaded, reduction in the life of the equipment, increasing incidence of fault. We experience frequent fault at different corridors given extreme loading conditions. Operational constraints, voltage and frequency limits, uncertainty of renewable energy sources. And now coming back to, so this is what the whole history behind the conventional energy grid, the current status, challenges that energy grid poses today, and what we are aiming in next 5 years, that is 2021, what kind of energy growth we are expecting, what type of sources, especially the integration of renewable energy, as well as in 2040 we have to add actually huge amount of energy sources across different energy mix, starting from thermal, nuclear, hydro, renewable, all segments the energy installation has to grow, though the majority may be from renewable energy sources. But what do we understand, because this is anyway grid. So, the question is, are we currently operating an energy grid which is not smart enough, or what do you understand by smart grid, or what makes a grid smart? The digital technology that allows for two-way communication between the utility and its customers, and the sensing along the transmission lines is what makes the grid smart. According to customer perspective, if you already manage activities such as personal banking from your home computer, imagine managing your electricity in a similar way. For example, customers will no longer have to wait for monthly statement to know how much electricity he or she use. With a smarter grid, he can have a clear and timely picture of it through smart meters, can able to see how much electricity you use when you use it and its cost. Means combined with real time pricing, this will allow you to save money by using less power when electricity is most expensive. Means you can organize your consumption pattern based on the energy cost, time of use energy cost, so that your monthly energy bill can be made minimum as possible. Smart grid has the potential to help you save money by helping you to manage your electricity and choose the best times to purchase electricity, and you can save even more by generating your own power by putting rooftop solar. Now, the NIST, National Institute of Standards and Technology, provides you the pictorial view of how the smart grid conceptually works. Now, we can see there is bulk generation, and we have transmission, then distribution and customers. Now, we can say this is my operating center, and we do have energy market, and we do have service providers. Now, the very interesting part, that the thick lines you could see which is between operation to bulk generation, transmission, distribution, customers, the secure communication interface, and whereas these are the dotted lines, the yellow dotted lines shows the electrical interface, and these clouds are nothing but my domains. So, this is how the smart grid conceptually work, taking care of electrical energy flow interface as well as communication interface. So, this energy and communication interface together perhaps conceptualize the smart grid operation. Now, let us understand the standards of different standards of smart grid definition. Now, the first one, European Technology Platform for Smart Grid in 2006 defines a smart grid is an electricity network that can intelligently integrate the actions of all users connected to it, generators, consumers and those that do both, in order to efficiently deliver sustainable, economic and secure electricity supply. A smart grid employs innovative products and services together with intelligent monitoring, control, communication and self-healing technologies to it. It is mainly to better facilitate the connection and operation of generators of all sizes and technologies, allow consumers to play a part in optimizing the operation of the system, provide consumers with greater information and option for choice of supply, significantly reduce the environmental impact of the whole electricity supply system, maintain or even improve the existing high level of system reliability, quality and security of supply, maintain and improve the existing service efficiently, foster market integration towards modern energy systems. Now, let us finally understand the definition of smart grid in precise way. Now, US Department of Energy DOE defines smart grid in the following manner: Grid 2030 envisions a fully automated power delivery network that monitors and controls every customer and node, ensuring two-way flow of information and electricity between the power plant and the appliance and all point in between. This is what the definition of smart grid by DOE. Now, based on International Electrotechnical Commission IEC, the smart grid is a developing network of transmission lines, equipment, control and new technologies working together to respond immediately to our 21st century demand for electricity. Dear listeners, the smart grid definition vary, but as a whole the outcome of each definition remains same. The main intention here is to establish a strong communication, two-way communication or two-way flow information between the power plant and appliances has to be established to make your grid smarter. Now, the major duties of smart grid is more efficient transmission of electricity, quicker restoration of electricity after the power disturbances, reduced operation and management cost for utilities and ultimately lower power cost for consumers, reduced peak demand which will also help lower electricity rates, increased integration of large scale renewable energy systems, better integration of customer owned power generation system including renewable energy system, improved security, and if you now come to a reasonable conclusion to compare how the existing grid look like and how do we see the future smart grid will look like. Now, the existing grid, it is completely electromechanical and partially digital, where smart grid is expected to be completely digital. existing grid do have one way communication and the smart grid may have two way communication. Existing grid has centralized generation, smart grid will have distributed generation. Existing grid has limited sensors and smart grid will have sensors throughout. Existing grid is of manual monitoring and smart grid will be self monitoring. Existing grid will be may come across failures and blackouts, but smart grid will convert them into adaptive and islanding mode of operation. Existing grid will have limited control mechanism and the smart grid will have pervasive control mechanism, and existing grid achieve manual restoration and smart grid is expected to have self healing mechanism. Now finally, let us have a look to the smart grid architecture. Now in the smart grid architecture we will have the main energy management system. Now we could see that the distribution stations taking power from solar, energy storage, and we could also see the wind power plant. They all constitute renewable energy sources, and then we can experience hydropower generation, and through underground cable they can be interconnected to the same energy management systems. The energy from thermal, nuclear, other source of energy, and these are all our smart houses. So we expect the smart grid architecture will wonderfully connect all residences, electric vehicles, cities with renewable energy sources through an efficient energy management system. So this is what we expect the smart grid of the future will look like, and so called smart grid architecture of the future. Now the smart grid components are of the major components of smart grid are classified as follows. We will have smart infrastructure, smart communication, smart management as well as smart protection systems. Now the smart infrastructure system is further divided into two parts: smart energy system and smart information systems. The smart energy system will be of power generation type, transmission type and distribution type, whereas the smart information system will have smart meterings, sensors, phasor measurement units as well as information management. Now with this we stop at our first lecture today, and in the next lecture we will continue with the introduction to smart grid by understanding the detailed components and their characteristics, applications of smart grid in detail during next class. Thank you.